Hello. The antiderivative for sine squared of x came up recently, and I wanted to run through not only how we figure that one out, but also the antiderivative for cosine squared of x. So you're going to have to dig back to your days of studying trigonometric identities, and what you're going to hopefully remember or look up is that we have an identity that says the sine squared of x is 1/2 times 1 minus cosine of 2x. And the only way we're going to be able to deal with this indefinite integral is to convert that sine squared of x into something else. Namely, we're going to replace it with this. So we're going to essentially do a u substitution. I'm going to substitute this thing into the definite integral. So the way we attack this is we write this integral out as the integral of, and then I'm going to replace, I'm going to replace sine squared of x with 1/2 times 1 minus cosine of 2x dx. And this is actually the antiderivative that we're going to run through. Now, when we get all done, we're going to just put a box around this thing and call that the antiderivative. You don't have to run through this work every time once you've done it. Okay, so now I'm working on this problem. And I'm going to kind of clean this up a little bit. I'm going to break it into two integrals. So when you distribute this 1/2, you get a 1/2 here and you get a 1/2 cosine 2x there. So let's break this up on the minus sign. And we'll have the integral of 1/2 dx minus the integral of 1/2 cosine 2x. And you can stick the 1/2 out here if you want. That's barely a 1/2, isn't it? Let's give me a little undo here, and I'm going to write that a little better. Slightly better. 1/2 cosine 2x dx. Okay, now this antiderivative over here on this side, this is pretty easy to deal with. That's just 1/2 x. Okay, this one is a composition. We've got a 2x plugged into a cosine. And so to do that one, we're going to need some u substitution. So let's do this in two steps. I'm going to just knock out the first indefinite integral right now. This is x over 2, right? 1/2 x. And then I still have to deal with this one here. And we'll deal with that one using u substitution. So I think you'll agree we're going to make u equal 2x. And that means du over dx. Let me scroll this thing up a little bit. Du over dx is what? 2, and that means dx equals du over 2. So now I can write a new definite integral, and indefinite integral. I've got my x over 2 still, minus. Then I've got my 1/2. My new integral will be the cosine of u times du over 2. And then I've got to clean this thing up and wrap this problem up here. So that's x over 2 minus 1/2. And then I've got this 1/2 here that I'm going to bring out. So that's another 1/2. So that's going to end up being 1/4. And then I've got the antiderivative of cosine u du. Okay, so I've got x over 2. Let's move this up. I'll zoom back out so you can see the whole thing in a minute here. X over 2 minus 1/4. And then the antiderivative of cosine is sine of u. And then don't forget that huge plus c. And then what was u equal? Oopsie. Let's get rid of that. U equals 2x. So to finish this thing off, and then we're going to put a huge box around it, this is going to be 1/4 sine of 2x plus c. And from this point forward, when you see the antiderivative of sine squared of x dx, you know that this is the formula that we're going to use. Let's put a huge, let's make it a big green box around this thing. So this is our antiderivative. Just add it to your list of antiderivatives so that you don't have to go through this process every time. Now, just to show you what we did here, the whole thing, here's the whole thing. All right, and you'll notice over here on the side, I've also got the cosine squared that I want to run through here, and it'll be a little faster. Maybe I'll talk less when I do that, but let's draw a green line in between these, and then we'll slide over and we'll do this one. And we'll have them both right here, okay? So we're going to slide over and do this one. Let me zoom in on that. And the identity that we'll use for this one is similar. It is, and you probably remember this from your studying of trigonometry, but the cosine squared of x equals 1/2 times 1 plus cosine 2x. The only difference being that plus sign right there. That's the difference. And as you know, we're now going to rewrite this integral, and then we'll split it up and do the substitution just like we did. So this is going to go fast from this point forward. Oopsie. Okay, so let's rewrite that thing and get it going. We're going to do this integral. I'm not even going to change the color because we know where this is headed. This is 1/2 times 1 minus cosine 2x. And it breaks up into 1/2 dx. Ooh, that's a plus, sorry. Remember, for cosine squared, there's a plus sign. So this is plus 1/2 cosine 2x dx. And since we already did all the u substitution, I'm just going to skip to the punchline here. We know the only thing that's changed is a plus sign. So let's take advantage of that. This turns into x over 2. This turns into plus 1/4 sine of 2x plus c. And so now we can say with some confidence that the integral of cosine squared of x, is going to equal x over 2 plus 1/4 sine 2x plus c. And we'll put a yellow box around that one just to be a little different here. And then we'll zoom out and we'll look at all of this. That's barely a box. Okay. Let me turn this off and zoom out and see what we've got here. So there you have it. When you see an antiderivative or an integral or even a definite integral for sine squared of x or cosine squared of x, now you know that we have these formulas available that will help us to quickly write those down, and you won't have to worry about deriving them for yourselves. Okay, that's enough for a Thursday morning snow day. You know where to find me if you need me. So in the meantime, take care.